Welcome everyone to today's webinar. It's going to be on forest road planning basics. I'm Erin. I'm going to be the host per usual. I seem to keep getting this card where I get to host webinars. Anyways, per usual, please ask questions through your GoToWebinar panel as we go through the webinar, but excited to present for this one. So we have a quick little agenda here. We're going to start off talking a little bit about LiDAR. You know, obviously it's growing in popularity, growing in usage, getting a little bit cheaper for acquisition. So we're going to talk a little bit about working with LiDAR and our software and what that means in terms of bringing in the data and workflows. And then we're going to use that LiDAR to explore deflection and cable logging location options as well as landings. And for those of you who are not in terrain that's suitable for cable logging, kind of skip that step or grab a cup of coffee, because then we're going to be talking about pegging road locations and how you can start to plan and evaluate different options for roads through a technique that we call pegging. Lastly, we're going to be showing you how to use a road template to create a landing at the end of our road. And that's the landing that we'll have planned in the second step. So before we get into the formal software piece, I did just want to highlight, obviously we like to do this, a few tips for working with your LiDAR. LiDAR data sets can get very, very big very fast, and a few tips for helping keep your computer functioning well and reducing it. So the first tip we have obviously is to try wherever you can to use what we call raw LiDAR and avoid gridded data. Gridded data, and this basically is just inferring little tiny points between your main LiDAR points. It really doesn't improve the quality of your data at all, actually. It just adds a tremendous number of points to your model. So if you're working with a post-processing software, if you've got a consultant or a contractor that's providing you with LiDAR, ask them to avoid gridding it if you can. Secondly, and we'll talk about this one in a bit more detail, it's really to selectively thin your data. We don't need to work with full resolution usually across our entire area, entire model. We can thin it to our area of interest or to a specific corridor. So naturally, the fewer points that you have in your model, the faster that model is going to work. And there's a whole bunch of different workflows around thinning data and importing data that really depend on, your specific data set. And we'll talk about a bit about that next sort of concept in a moment before I pass it over to Dave. And our third tip, this one applies specifically to LiDAR data that's coming in sort of as an ASCII data set. And this is just combining features upon import. It saves a tremendous amount of memory and makes it a lot easier to work with it. So the other piece I wanted to address before I pass it over to Dave, he is going to show you one workflow example today for working with LiDAR. There are a lot of different workflow options that exist with our software. We've got two different areas that you can thin your LiDAR at. You can thin it at import, as well as you can use a LiDAR thinning tool after import. So you've got a bunch of options, and it's kind of, depending on your data, the workflow that's best suited for it, is going to vary. And our team here and our support team always willing to answer a call, to field any questions that you have about how to work with your LiDAR. And what workflow works best for you. But we've got, as I said, you can import tiles all at once. You can import tiles individually. You can keep them at full resolution. You can thin them at import. You can crop them at import. You can thin them after import with our better quality thinning tool called point simplification. And then you have options you can design using that full resolution data depending on how big your area is and how big your data set is. You can design your roads and features on thin data and just keep it as is. Or you can design it on, very thinned data as an initial concept and then re-import and re-thin your data. And one of the ones that Dave is going to include today in his example, he's actually going to crop the LiDAR on import. So selecting a specific area of interest that's a little bit narrower than the amount of tiles he's got. And then he's going to show some thinning techniques and work with it from there. So a lot of different workflow options. There is no one-size-fits-all workflow. It really depends on your data. And with that, I'm going to pass it over to Dave and let him take you through today's webinar.
Thanks, Erin. Okay, we're working with the terrain module to start, so let's load up terrain module version number 9. Got a new splash screen here. We're getting ready to release version 9. What I'm showing you today is in both version 8 and version 9, so you don't have to worry about new features that you don't have yet. But and there is one feature I will not show you, but Live Map for importing images is pretty cool in version 9. Okay, so let's first of all get ready to import some LiDAR data. Now, I don't really want to bring in all my LiDAR data, and I want to make sure I've got it in the right spot. So I'm going to open a shapefile. Which shows the proposed block boundary. There's one, and I got another one in there too. Now, I'm using File Open here because actually I can use Insert too. Let me do that. Insert File, Shapefiles, and here's a little gotcha. Shapefiles come with an extra XML file. Do not try and open an XML file as a shapefile. It will fail. Anyway, if I pick this item from our import list, shape, then it only shows the shape file heading, and those are the ones I want. And I want this block boundary and that block boundary. Whoops. Shapefiles come with a projection. So I'm going to set my current projection to be the same as the shapefiles, which is perfect. And it does that automatically. Great. So here's my two blocks. I'm going to bring in one more little thing. Let's bring in my existing roads. So hopefully, and of course it's in the same coordinate system, so there's no need to change any options here. There we go. When you're importing shapefiles, it's nice to sometimes import them one at a time, and then they come in selected, and you can modify lines and color. So for example, I just imported roads, so let's change the line type and color to be what I want to see for roads. Okay. Now the great thing about this file now is that I've got my two logging openings on the screen, and now I can bring in the LiDAR and see if it's in the right spot. Okay, so let's again insert file. This time I'm going to pick all my LAS tiles. There they are. You want to, in general, use insert file when you're bringing in LiDAR data. First of all, because you can use the existing features in your terrain. And when you use file open, it deletes everything and starts again. So insert file. The other great thing about insert file is it allows you to select multiple features, or multiple files, sorry. Okay, so here's all my LiDAR points. Now if I click on examine, it'll go away for a while and think, and it'll tell me how many user-defined points I have. Now this data set is unusual because they're all set as user-defined, and normally number 2 is called ground points. And this is the first LAS I found where it just says user-defined. So whoever set it up was a little sloppy. And it's not clear how many points I've got here. So examine files will tell me. The other way to tell how many points you have, and I encourage you to do this, is to just read the whole thing in. Make sure you've got number 2, ground point, selected, but thin it out. So I'm going to read in 1 in 10 points. I'm not going to bother changing any other selection. I'm just going to read in all these files. So there's half a dozen of them, and it takes a little while to read each one. So if you remember Aaron's little flow chart, this is thin at import, and there's my data. And you can see it coming up on the screen. Let's just zoom extent so we can see it all. And I've obviously got some data outside my area of interest. The blocks are over here in this blob, and then I got this stuff over here. Okay, so 2 things I've learned. I've got data in the right location. So I can't remember whether it prompted. Normally it will prompt you and say coordinates undefined. You know, do you want to read in these points? These points are in an LAS file. LAS does not come with a projection. I'm in the right projection because the data is landing on top of my shapefiles. So that's good news. The other thing I can see here is that I've got 269,000 points selected. So I read in 1 in 10. That means I've got 2.7 million points in the whole file in the ground points. Okay, those are good things to know. I'm going to delete these points and now read in a cropped set of data. So how do you crop data? Well, you build a polygon. So let's make a little polygon here. Call it AOI for area of interest. Doesn't need to be 3D, just a rectangle. Now I don't want to draw a rectangle by hand, so I'm just going to use this little feature operation to convert my diagonal into a rectangle. There we go. Right. So that looks like a good area of interest. And now I'm going to read in my data again, cropping it. So insert file from the home ribbon, pick them all, and import options. Okay, I don't really need those borders. Let's turn those off. User defined, yes. Notice that the total number of points is quite a lot larger than 2.6 million, 43 million. So the other points in those files are not ground points. Now I'm going to use my selection tab to do some cropping. So you can have various types of thinning at read time. This is before we've actually opened the files. And I'm going to use a polygon, which I called AOI. There it is. That's the feature I created. And here's the other features in my terrain. Now I've got two regions that I'm reading in. Default, let's skip them all. I don't need anything outside my area of interest. Polygon 1 area of interest, I want to read in every point, so I'm skipping 0 or slide the slider up to high. Okay, let's get that started. It'll take a second. Yes, here we are. Incoming coordinates are undefined, and that's normal for LAS files. So if I'm not sure, I can actually cancel here, and I can change the incoming projection and do a transformation if I want to. The fact is, I've already tested this data, and I know it's in the right coordinate system, so I can just continue. It takes a tiny bit longer to read with a rectangle area being cropped. There you go. There's all the data points. Now that's full resolution, and it's showing, here we are, 1.8 million points. That's still a lot of points, but certainly nothing beyond what Rodensch and terrain can handle. However, I'd like to thin it even more. So let's just zoom into an area in here. And notice that the data is very dense in places. Now, I took the trouble a little while ago to look at some of these points, and they're less than 1 meter apart in here. Now, there's other areas that are a little bit less dense and sparse. Now, if I had thinned my data at read time, it would thin it all uniformly, and it would actually maybe remove some of those critical points in the areas that are quite sparse. I'm going to use now the terrain modeling simplify option to thin data in a smarter way. What this does is it builds a grid. I'm picking my grid size as 1 meter, and it's going to remove all but one point in every grid cell. So points that are already isolated will not be removed. They will guarantee to stay in the model. points that are very dense, where there's 2 or 3 points inside that 1 meter grid cell, it'll keep one of them and throw the others away. Let's see what that does. So I simplify my data, and it's reduced the number of points from 1.8 million down to, looks like 1 million. Oh, those numbers were wrong. The actual number of points has been reduced down to about 756,000 points. Okay. Let's take a look at them. And you can see they're more uniformly spaced. The sparse areas are still sparse, but there's no points removed from there. The dense areas are now roughly 1 point per every square meter. Good. Now I'm going to make a surface out of that. I don't need my area of interest anymore. Let's just delete that. And I'm almost finished with LiDAR import. At the end of this whole exercise, we could go back and re-import to bring in data at higher density near my road. We'll talk about that later. Okay, so I've now got a fairly accurate model with under 1 million points, so it's quite small by comparison. And I'm going to generate a surface. Okay, you've probably all seen this before. I won't go too much into the details here. One thing I want to mention, though, is that when you bring in multiple files, Terrain gets confused about the start and end elevations for your contours. Notice that the calculated range is outside of the numbers that are in there by default. So I'm just going to fix those. And I need to do that for both major and minor. I'm going to turn off labels. I'm going to bring in points. I'm going to make sure there are no large triangles. So 25 meters is the biggest triangle I'm going to create. We won't interpolate between points that are farther than that distance apart. Looks good. Okay. Great. Notice that the number of points, and you can see that down in the bottom of the screen here, the total number of points has gone from 700-something thousand up to 1.4 million. Those extra points were created by the contours. The contours have a lot of points in them. And if I do a little screen scroll here, it takes a while for the contours to draw. So I'm going to do one more thinning operation. I'm going to select all of the contours. When you select by name, it's a good idea to unselect all first, or at least notice that there's none selected. And then here we are, CNTR star, so that'll pick up the contours and the major contours, which are CNTR M. There they are. So just like you can simplify the points in a surface, you can also simplify the points in a feature. And what that does is it just removes points that don't really add to the shape of the feature. You need to put in a tolerance. I'm going to say 0.2 meters is my tolerance. That will mean that the resulting feature with fewer points will not deviate from the original feature by more than 2.2 meters. Okay. Notice that we have 700,000 points selected, 208 features. Those are the contours. After my simplification, we only have 50,000 points selected, and the draw time is way faster. Good. Now I've got a surface, and I'm ready to go on to my next step, and that is to try and find a landing location by using our cable analysis software. Let me just save this in case something goes wrong. So I've already got it on here called Topo 1. I'm just going to call this demo. Right, so cable analysis. New feature in version 9. Oh, I lied at the beginning of the webinar. This is brand new. This cable, we call it Explore Deflection. And let me demonstrate. So here's all our logging systems. These are, they used to be called logging setups in version 8. I've got one here called Grapple. It's been on my hard drive for a while. It's been set up already. In general, you know, you want to set these things up beforehand, and you can do that in the logging setups tool on the cable analysis ribbon. Okay, so I'm going to pick my Grapple yarder as my current yarder, and I'm going to choose a calculation. Now there's a few options here. This one and this one make sense for a Grapple yarder, which is a running skyline. Simple third point deflection works for everything, and it really is simple. So let's use that to start with. It really doesn't do a calculation, it just draws a picture. But it also can determine when the 10% deflection hits the ground. Okay, and these options allow me to choose the length of my exploratory D-lines, the number I'm going to try, and this is the tail hold spar height. Auto position means that the tail hold will be moved out away from the landing until the deflection hits the ground. And then show area polygon. I'll show you that in a sec. Okay, so let's see what this does. What this does is it changes my cursor. We've got this enable button depressed, and whenever I click, oops, I'm falling off the model. Let's not look at that again. I don't need it. You can see a whole bunch of deflection lines and a polygon which connects up the ends of them, and an area, 11.6 hectares. So it's a good way of telling whether you've got coverage of your block and from where. So for example, down here, you can see that I'm actually getting good coverage of that area. And when the, yeah, that's a good spot. Let's pick that spot right there. So I click on the accept button, and you can see all the cables have been drawn now. They're no longer faded. They're full brightness. There's my polygon that represents the area. Of course, it has a well-defined area, 12 hectares. And we're kind of covering a little area we don't need over here, and we're a little bit short over here. What do these deflection lines look like? Well, let's pick one. Whoops, hit the contour by mistake. Let's pick a deflection line. There it is. They're all called DL Explorer, so they're easy to select and delete with select by name. Let's create a profile window, show them side by side. So there's my deflection for this particular one here. And you can see as I move out from the landing, this point where it puts the tail is the location where it's just about to hit the ground. If I move the tail out, it's going to submarine through the dirt. And that's not necessarily impossible. It just means you've got partial suspension, or at least the carriage is dragging on the ground. Is that true? The log's dragging on the ground. The carriage will probably go up higher. We can use now the cable analysis tools to actually adjust these things. And like here, for example, I might want to just change the tail position. I should have looked at that first. Say I want to go all the way out to there. That's my my tail position, and you can see that station number is oh, no hover tip. How annoying! It's about 150. I can read it off the bottom here. So I'm just going to change my haulback block position to 150 and apply. There we go. And you can see it's going underground a little bit there. That would be no problem if we change the calculation to have a smaller percentage for deflection. There you go. It's above ground now. Okay, so you can modify these things. You can delete them. You know, they're just features. It's easy to select them all by name. You can select them all by going here, actually, just by dragging a little rectangle around the center. And you can also change other features like calculation parameters. This is going a little beyond where I wanted to, a little more detail than I wanted to cover for deflection lines. So let me go back to the Explore mode. I'm going to delete these. Do I need to? No, I can leave those in there. Sure, what the heck. Go back to Explore mode. So again, you can pick from a yarder that you've already set up, choose a calculation. This one works too. This is doing a real calculation. It's calculating cable strengths, cable tensions, all that stuff along the alignment, along the D-line. Let's see what that looks like. Okay, so that's kind of a smaller area. If I go back in here, change the load to be smaller. I went from 20 to 10,000. And click again, you can see I'm getting a larger coverage. So set up your DL or D-Line Explorer configuration to match a reasonable yarder and poke around and see if you can find where you want to put your landings. Well, let's assume this is a good landing right here. So I'm going to choose that as my landing point. Actually, I already did this earlier, and I put a feature on the surface where I want the landing to be, and I want to now go into the next part of my planning operation, which is to try and find a road that will connect up to my landing site. Okay, let's just reopen that terrain. So here's a terrain with the landing on there and some existing roads, and I want to build a road to get to the landing. So really, I need to go to my location module and do road design. Now you can draw features on the terrain in the terrain module and look at the profile, but really it works better in location because you get so much more information at the same time, not just the profile, but cross sections and grade labels and so on. So I'm going to switch to my location module. And I'm going to create a new alignment. So I'll use that same terrain. Sure, we'll start on the current point. When you create a new location design in RoadEng, it does a couple of things automatically. It opens the normal screen layout, it reads in a cross-section template from, let's just look at all our templates, from a table called normal TPL. And here's all my templates. I've got a default roadway template that looks like this. I think it's about 6 meters wide, 3 meters each side. And big ditch, steep slopes, pretty typical forest road, daylighting over here. And I put another one in this table called landing, and that just puts an extension on both sides. But we can choose left or right when we assign the template. Right, so let's design this road. I want to go from the existing road over here to my landing, which you can see there. So let's pick that point and move it over there. Could have gone the other way, but it's traditional to go from outside in. Create a new alignment point. Let's stick it right on the landing. I could snap if I wanted to, but then I find I'm always snapping to the contour. So I'm just going to get it lined up as well as I can. This warning is usually not a problem. All it means is that the cross-section will be a little narrower than it should be, and the default width is 500 meters on each side, or 500 feet if you're working in imperial units. So not a problem. Don't show me this message again. You can see that cross-section is plenty wide. Okay, what does that look like in the profile window? There it is. Now I could start designing here for vertical and horizontal alignment, but at this point I want to do something called pegging, and I've got a screen layout for that. And this comes with our training tutorial. If you download the training tutorial, it'll be in here under training pegging. There it is. And I've been modifying it slightly, and I've stuck one up here in my regular screen layouts folder. And it looks like this. So let's just zoom extents on the profile window. Zoom in a little bit on the plan. So we can see the cross-section. We can see all the legs I've created, all the horizontal alignment PI features between PIs. And you can see a big grade on the plan window. So yeah, if I move my alignment, everything updates. Profile, cross-section, that's 21%. So I couldn't go probably straight up if I wanted to get to this point. I'd probably have trouble getting there. You can kind of peg along the alignment like so and watch the grades. But for this particular road, I like the idea of just getting it from beginning to end and then try and straighten out this profile here. So it looks like it's a pretty steady grade up to about here. So I'm gonna stick a point in there. Now you can see I've got two tangents, one at 9.8%, one at 7.9%. Let's lower this one down a little bit, try and make them more equal. And then I'm going to try and get rid of these bumps. So to do that, I want to track the contours as best I can. I mean, I'm not following a contour because I'm going uphill, but you know what I mean. So here I'm going to go down a little bit. You can see that's kind of tracking the contour, and you can see the cursor moving in the profile window. And if I go over here, so here's my gully, and yeah, obviously that point should be up here. And you can see the cursor moving in the profile window, so that looks about right. This would be too high. This would be too low. There, and that gives me a grade of 10%. And it smooths out that bumpiness. And here, same thing. Let's just smooth it out a little bit. Whoops, too far. That's better. And then there's a big bump here because of that curve in the hillside. You can see the profile is flattening out. I'm going to stop there. So those are the kind of things you can do to peg in an alignment. Now that I've got a horizontal alignment, I need to design the vertical. Let's just save this. I've already done this before, so I'm going to call it number 3. And now let's put in the vertical alignment. So I'm just going to open my normal screen layout again. Now my screen is a little bit small, so I've got the profile behind the plan. Pretty straight grade. Let's just go up to the end of the road, and then let's make it a little bit flat at the end because that's where the landing's going to be. And now I've got a steady grade in here. I can go back to my horizontal alignment and try and get rid of any large cuts and fills. You can see the large cuts and fills just by looking at the slope stakes. And I can do that with horizontal alignment. So for example, I could move this point downhill a little, uphill a little bit. There we go. Uphill a little more. And eventually I'll get to full bench. I've set up my section window. That's part of my screen layout to do horizontal alignment. So that means I can just move in here if I'm in edit mode, pencil cursor, edit mode. You just move into the section window and click and move horizontally, and that allows me to do horizontal alignment from the section window, and it's easy to find full bench. You can even go to points that are not horizontally aligned yet, like right here, for example. If I move horizontally, it adds a new horizontal alignment point in the section window. This point needs to move, so let's move ahead or do it in the plan. You can do it either way. It's up to you. Now, I don't really want to spend a lot of time doing alignment design with Roadeng, because this is all about planning, but suffice to say that you can build a good vertical alignment on this surface, and now we've got a reasonable road. Okay, now I've already done this. Yeah, you know what? This road's fine. Let's just stick with it. So I'm not even going to open the other one. I will do a save as though. Save as and rename is a good way to kind of back up your work as you go along. Keep your old files, then delete them later. Okay, so we've got a reasonable road design here. Let's put in a landing. So let's go from about here, 660, to the end with a widening on the left. Assign by range. We've been using the default template since we started. That's the default. That's why I called that. So I'm going to put the landing template in. Now, I actually only want it on the left-hand side. If I put it on the right, it would cause a sliver fill, right? So I'm going to click on this button for left only. Notice that it messes up my choice up top here. So generally, you want to click on left or right first, and then choose your template, and then choose your station range. 660 to the end, add, there it is, landing's in there, recalculate, and There it is. So this is the cross-section before, and as I move through the alignment by clicking on these little buttons down here, there's my landing. It's got a slope down to the ditch, and it's much wider than the original road. That's one way of creating a landing. There are two more that I want to show you. First of all, I'm going to put one right here. Okay, so that's around station 200. And this time I'm going to use the, whoops, wrong button. I'm going to use the overrides tool. So if I change the width of my road, that width is the parameter that's used to control the template width. I can override that. So I'm going to override it at station 200. Now I'm not going to make a landing, I'm going to make a turnout, and I'll show you why it's not suitable for being a landing. Okay, so turnout at 200. I'm not even changing from use default. I'm just putting in the range that I want my road to be wider. Now I'm going to make it interesting by changing this, 200 to 300? Sure, what the heck. Actually, no, let's just modify that back to 250. Okay, duplicate. Add another 6 meters on the left side. This is the width left to make it 9. And at station 240, do that again. This duplicate button is nice because it saves you typing a description, and it remembers everything you did before, and you just got to change one parameter, in this case the station number. And there is a turnout. It's got default width up to 200, then it tapers up to 9 meters at 210, stays at 9 meters until 240, and then tapers back down, and it remains the default from 250 to the end. So I said this wouldn't be suitable for a landing. I think the main reason for that is because it's actually putting the surfacing on, whereas the landing template didn't do that. But it's up to you. So basically, you can modify the shape of your cross-section using either a template or an override. Templates are a tiny bit easier to assign, and overrides have this other feature here, which is kind of cool. You can select an override, generally 4 points, and duplicate it and move it to a new station. So let's say 100. So now I've got two turnouts, one at 200 and one at 100. The third way that you could create a landing is to use our terrain module to actually build a pad and merge it into the surface. Now I'm not going to cover that here, but that's yet another way. Treat the landing as a separate structure and use our grading tool in the terrain module to build a landing, and then put it into the original ground terrain and build your road to join to it. Okay, I'm pretty much finished. Now there's one more little thing I wanted to show you. We've been designing the road on the terrain that I created by thinning the data. It's actually possible to switch terrains at any time. And I made a terrain. Let me just show you what it looks like. So here's the terrain we just created at the beginning of this webinar. And if I select all points, Control A, you can see that they're pretty uniformly distributed. Now I'm going to show you another terrain that I created. Now it looks the same, but if we zoom in a little bit on this roadway here and look at all the points, you can see that the points near the roadway are dense, and away from the roadway are less dense. Oops, it keeps redrawing here. We don't need to see that. So how did I do that? What I did is I brought in the data at full resolution like we did before. I don't have an example here. And then, instead of just thinning everywhere, I picked this feature here. Well, I didn't have to actually pick it. I have to know its name. It's called CL. That's been exported from my location design. And I did my terrain modeling thinning with an excluded region, corridor CL. There it is. Like so. There's a 100-meter swath around center line that will be excluded from the thinning. So now I could thin this data and it would leave that data untouched. Yeah, let's just thin it down again. I'll show you the results. We won't save this one. Okay, it's removed a whole bunch of points. And now if I look at all the points, you can see very clearly what it's done. So like I say, I did that with Topo 2. If I go back, let's close this without saving. If I go back to location design, I can switch topos now. I can just go to my setup, location, alignment, terrains. And I can just switch out my topo terrain and use a different one. So why would I do that? Well, the idea is that the different terrain has a more accurate surface in this zone. So when I calculate things like cross-sections and cost values, or even use our optimizer, you're getting a slightly better result than if you used a thinned terrain that had points removed from the surface. That's all I wanted to cover today. If anybody has a question, please type it into the questions area. Oh, I have a question.
And while Dave reads that, I have a small public service announcement. If you happen to be someone who speaks Spanish and perhaps you're watching as English as your second language, we are actually running this exact webinar using the Spanish version of RoadEng in full Spanish support next week. It's the same day, slightly different time. It's going to be at 8 a.m. Pacific next Thursday, Spanish RoadEng featuring Forest Road Planning Basics. Dave, hopefully you're ready to answer your questions.
Yes, I am. Thank you. For planning, we need additional spur roads. How can we add, etc.? Okay, so I showed you how to make one road. We can actually, in version 9, we can have multiple horizontal alignments. I'm not sure it's worth the trouble of doing that, but there's certainly nothing to stop you from designing more roads. You could either create a new horizontal alignment here and just start designing, or you could just create a new road, new file, pick the same terrain and design your alignment. The nice thing about the multiple horizontal alignments is that you can, let's do it. Let's call this spur. So you can see both of them at the same time. So here's my spur road. Oops, that's not right. Did I just duplicate? Let me reopen here. I think I did the wrong thing. No, I don't have to reopen. I'll just delete it. Oh, all I did was rename it. Yeah, okay, sorry. Let's do that again. Go into the alignments panel, click on Add. Yeah, I renamed this one. Let's call this Main. And then click on Add, New. You can duplicate the existing if you want, or add new, and call this one Spur. Okay. What? Oh, it didn't accept my name. Oh, there we go. Okay, so I'm getting the same dialog box I get when I do File New. I have to choose a place where I want the alignment to start. I'll just pick Center of Terrain. Oops. There we go. So my first point ended up here. I can move it to where I want to actually start the road, and I can design another road, and you can see the old road in the background. Now, this is kind of nice for organization because it saves it in one file, but other than that, it's not much different from just having multiple alignments. Yeah, so we probably would have also done a little more D-line exploring and chosen other locations for landings so we'd have a target. And you know, in this particular design, and I can show you this in the terrain module, the people who were kind enough to lend us this data had designed a road going in and had switchbacks going up here. So yeah, I mean, pegging roads is easy when it's nice and straight like I had. It gets harder when you're doing switchbacks, but the same tools are extremely useful, and it does work. Yeah, if I put in a switchback here, let's go to pegging. It's hard. you gotta, you know, you get these classic switchback situations where you know the first leg might be okay and the second leg might be okay, but it's super steep up here. There's the zone where I'm going through the switchback. It's very, very steep, so we're going to have to cut down here. We're going to have to fill down here and cut up here, and yeah. And you probably need to put curves on too. So switchbacks are hard. Any other questions?
I think, Dave, we've gone a little bit over time, so perhaps just grab one more of the ones left here on the panel.
Oh, yeah. Can you put the cable planning in the background of terrain, of location? Of course you can. What I didn't do is save any, in this particular design, I didn't save any of my cable planning D-line roads. So if I just switch to the background that I'm using, everything that I do in here is visible in location. So I can't use the okay, let's just set this up quickly, sorry. Can't use D-Line Explorer from location module, but if I use it here and accept it, those features will be visible. And there they are.
Excellent. Well, Dave, thank you for being our presenter and leading us through this webinar. I hope everyone really enjoyed it. A video of this webinar is going to be available probably within the next 24 hours or so off our YouTube page, and as a registrant you're going to get an e-blast with a link to that. And yeah, if you have any other questions, and for those couple questions that we didn't get a chance to answer, we'll follow up with you after the fact. That way we can let everyone go. But yeah, enjoy the rest of your day, and thank you very much for attending.
Bye now.